to be honest, I don't really have much time to actually explain the whole chapter, so I'm just going to discuss the answers in the analysis of the topic book. Even though the syllabus is based on last year's syllabus, however, this chapter is mostly similar. It's just in last year's book it was in chapter 3, but in this year's book it's chapter 1. Okay. I think it's the easiest way for me to get through most of the things possible, because it will help you to know what to expect during the exam. Number 1, which substance is used to change iron 3 ion to iron 2 ion? Since it's Fe3 plus to Fe2 plus, it loses electrons, so it's reduced. So you're going to find a reducing agent. So if I look at the answers, this is I wrote it wrong. It's supposed to be B, potassium iodide, because potassium iodide is a reducing agent. So you have to know that some of the reducing agents and some of the oxidizing agents. For example, for oxidizing agents, they include potassium dichromate, potassium manganate, both acidified, chlorine and bromine water, iron chloride, FeCl2, and hydrogen peroxide, H2O2. For reducing agent, it includes potassium iodide and potassium bromide, as well as iron sulfate, zinc. This is iron 3 chloride, by the way. Zinc or any other reactive metal such as magnesium. And let me see. I might take out some my teacher's notes for a bit. I'll look at here. Let me see if teacher wrote it here. Oh, here. This one. Chlorine water, acidified potassium manganate, 7, and acidified potassium dichromate, 6, hydrogen peroxide, and concentrated nitric acid. For this one, magnesium, or any other active metal, sulfur dioxide. It didn't say here, but it says hydrogen sulfide, as well as sodium sulfide solution, and tin chloride. But the main things that would probably be asked would be normal reducing metals such as zinc and magnesium, or potassium chloride. Okay, 5% mercury winning, lol. Okay, number 2. What is the IUPAC name and oxidation number? So since here, oxygen is always going to be -2, so copper is +1 times 2, so it's +1 and -2. So it's copper 1 oxide with an oxidation number of +1. Which of the following occurs in oxidation reduction? In oxidation reduction, you gain hydrogen, you gain oxygen, you lose hydrogen, you lose electrons, or you increase in oxidation number. So the answer is D. Which equation represents a redox reaction? You have to look at the oxidation numbers. So in this case, since Ag went from +1 to 0, while zinc went from 0 to +2, we have a redox reaction because it involves both reduction and oxidation. Number 5, the half equation represents the reduction of acidified potassium dichromate solution, 6 solution. What is the value? Okay, so if you know the formula of it, you should know this already. But if you don't know, 7 times 2 is 14, so x is equal to 14. After that, there are 2 chromium. There are 2 chromium atoms here, through chromate ions. So Z is equal to 2. So Z is 2. And then the electric charge, since we have 14H plus, so it's 14 plus. And then Cr2O7 2 minus, so it's 2 minus, and 2 minus, so it's equal to 12. Here is 2 times 3 is 6. So 12 minus what equals to 6? 6. So y is equal to 6. I hope that's understandable. Which of the following is a reduction reaction? Bromine molecule gains electron, because if you gain electron, you are reduced. If you gain oxygen, it's oxidized. If you lose electrons, it's oxidized. If you lose hydrogen, it's oxidized. Actually, wait. Yeah, if you lose electrons. Zinc atom loses electrons. Wait. Bromine molecule gains electron. Oh yeah, I agree. Gaining electron is reduction. You lose electrons is oxidation. Losing hydrogen and it's also oxidation, and oxygen gaining is oxidation as well. Okay. What is the number of x in X04 minus? So you know that the total number is -1, and then x plus oxygen is always going to be -2, so -2 times 4. So x minus 8 equals to -1. So x equals to -8 plus 1, which is 7. Which of equations show that the reactant acts as a reducing agent? When the reactant acts as a reducing agent, it means it's oxidized. Oxidized means losing electrons. So if you lose electrons, that means the electrons appear on the right side because the electrons are sent out. Since they're not accepted, they're sent out. So 1 and 3 are on the right side. So the answer is B. I have the answers here, by the way, to double check. Which substance is a reducing agent? Again, you have to remember what they are. Acidified H2O2 oxidizing. Iron 3 nitrate. If you don't know, anything with iron 3 is oxidizing agent. Anything with iron 2 is reducing agent. For example, in that thing, iron 2 sulfate. It can also be iron 2 chloride, iron 2 nitrate. But anything that's iron 3 is oxidizing agent. Anything that's iron 2 is reducing agent. So this is reducing agent. This is oxidizing agent. Potassium iodide is reducing, while acidified potassium manganate is one of the more obvious oxidizing agents. Which of the following are redox reactions? Okay, now A, igniting the glass stove. B, washing all stained clothes with detergent. C, rusting of car's body. D, using hot pack to relieve muscle pain. Using hot pack to relieve muscle pain. If I remember correctly, this only involves heat. I don't think there's an actual reaction going on, so I don't think it will be 4. Then washing oil stained clothes using detergent. What actually happens there? How about I? Igniting the gas stove. Igniting the gas stove requires combustion, and combustion would cause I think it was some gases. Wait. Let me see. Rusting of car's body. Rusting of car's body is definitely redox because it involves the rusting of iron. And during the rusting of iron, water turns into hydroxide ions, so it gets reduced, while iron gets oxidized. So it's a redox reaction. So 3 is definitely correct. So it's either 1 and 3 or 2 and 3. Igniting the gas stove. If you don't know what they will do, I will go with the more reasonable one. Since you're igniting the gas stove, there's definitely going to be a chemical reaction. So I will answer I. I'm going to Google what is the igniting gas stove redox. Okay, no wonder. The redox reaction comes from the methane. The methane that comes from the gas inside. So that's how it that's how the fire lights are in the first place, and that's how redox happens. So if you don't know, you hear it first. Igniting the gas stove is redox, and rusting is always going to be redox. Anything related to rusting is redox. Okay, the following chemical expression of silicon from coal using coke. What is the Jensen oxidation number of silicon? So silicon alone is going to be 0, and silicon dioxide, in here silicon is +4. Don't ask me why, you should know by now. So it's B, +4 to 0. Which of the following is not an oxidizing agent? Chlorine gas is an oxidizing agent. No. Chlorine gas is an oxidizing agent, so it's not. It's not going to fulfill the answer. Potassium iodide, okay, that's the answer. Hydrogen peroxide, yeah, nope. Concentrated nitric acid. any acid is oxidizing agent. So you hit it here first. Anything that says acidified or concentrated, any acidified stuff is oxidizing agent. Anything if iron 3 is oxidizing agent. Anything if iron 2 is reducing agent. Any reactive metal is reducing agent. Chlorine and bromine are both oxidizing agents. And the two main things you have to know about oxidizing agents are manganate and dichromate. Acidified potassium manganate and acidified potassium dichromate. Yeah, the answer is B. Okay, what is the oxidation number of hydrogen in magnesium hydride? Hydrogen is always +1, but when it comes to a hydride, hydrogen's number becomes -1. So the answer will be +2. Actually, wait. No, don't have that. Actually, wait, never mind. Yeah, I am correct. It is -1. Why? Because magnesium cannot be negative, so it's going to be the positive ion, so it's going to be +2. So +2 plus 0 plus 2, 2H equals to 0. So 2H equals to -1, H equals to 2H equals to -2, H equals to -1. If you don't get what that means, the total charge of a stable compound has to be 0. Since Mg is known to be +2, two hydrogen ions plus the magnesium charge, which is +2, will become 0. So hydrogen has to be -1 for each. What is X in this thing? The answer is sulfuric acid. Why? I actually am not completely sure why. Because technically speaking, it works because sulfuric acid conducts electricity. I think it's because sodium hydroxide is not actually not actually soluble, while the others aren't even the others are either weak acids or they don't even conduct electricity. I'm not so sure, but the book shows sulfuric acid. So when you see this thing, note that this thing is going to be sulfuric acid. Next, which equation represents a redox reaction? Again, it's the same thing as the ones earlier. The answer is, I think, let me just see. I think it's A. Yep, it's A. Because Mg goes from 0 to +2. O2 goes from 0 to -2. So one is reduced, one is oxidized. A method to control the rusting of underground iron pipelines is through sacrificial protection. Which of the following is the sacrificial metal? When you want to use sacrificial protection, the outer metal must be more reactive than the inner metal. The inner metal here is iron, so the sacrificial metal has to be more reactive than iron. If you look at the reactivity series, it's potassium, sodium, calcium, magnesium, aluminium, zinc, iron, tin, lead, copper. So iron. The only thing above iron in this thing is zinc. So the answer is zinc. Which is suitable to change Fe2 ions to Fe3 plus ions. Since it's increasing in number, it is oxidizing agent. We need to find the oxidizing agent. Zinc powder is reducing. Bromine water is oxidizing. Sulfur dioxide gas is reducing. Potassium chloride is reducing. So the answer is B. Which metal is the slowest to corrode? Okay, so if they ask you a question like this, the one that takes slowest to corrode is the least reactive metal. Tin, zinc, and magnesium are known to be very reactive, so the answer is copper. Which of the following is Raja 8 shows a ship in the sea, which uses sacrificial method to prevent rusting. Metal X becomes thinner after several weeks. Why? Okay, so they use the sacrificial metal as well, and X becomes thinner. Why does metal X become thinner? A. Oxidation number of X increases. B. Atom X is easier to receive an electron. C. X is lower. an ion in the electrochemical series, and D, metal X reacts with seawater. So they are all the same actually. Actually, wait. Okay, oxidation number of X increases. The answer here is A. Now, why A? Let me see. Is it A? Again, I haven't really looked this before, so I'm trying to explain, but at the same time, I'm kind of dumb. So yeah. Now, X cannot be lower than iron, because if X is lower than iron, then the sacrificial metal thing will not make sense, because the sacrificial metal has to be more reactive than iron. So C is definitely wrong. X is easier to receive an electron. If X is easier to receive an electron, it'll be better as the cathode. So no, it's doing its job. It's not supposed to be. It's being an anode. And not if it's an anode, then it will become thinner. Metal X reacts with seawater. Does it really react with seawater? It more so reacts with the oxygen and the water. It's not exactly the seawater itself. It's the water and oxygen gas. So, which of the following explains the situation? Oxidation number of X increases. Let's see. Oxidation number of X increases. Oh yeah, okay, yeah, that makes sense. X, because X is being oxidized, that means its oxidation number goes up. Because it's oxidized. Oxidation means your number increases. Metal X reacts with seawater. Metal X doesn't actually react with seawater. That means the metal X doesn't react with exactly seawater. It reacts with the oxygen in the air and water, as well as the water inside, or something like that. But not exactly just seawater in general. Okay. What is the position of hydrogen ion in the electrochemical series? I forgot about this one. I think it's between lead and copper. Yeah, between lead and copper. It's iron, tin, lead, hydrogen, copper. And I believe hydrogen is the same for electrochemical and electroreactivity. I forgot already. But yeah, H is in the middle of copper and lead. That's why hydrogen can displace copper. Okay, diagram 5 shows an observation when lead strip reacts with hydrochloric acid, bubbles of gas are produced. Which metal is suitable to replace lead to produce the least gas bubbles? So you're going to choose a less reactive metal. So that will be A, B, C, or D. I think that will be, wait. Yeah, you want to choose the least reactive one, which is copper. So it's B. In the thermite reaction, aluminium is heated with iron 2 oxide to produce vigorous reaction and high energy to melt the iron. Northern iron can use. Okay, I'm not gonna read the whole thing. What should be done to obtain a reaction which reduces more heat? Let's see what it says. Use aluminium powder. Replace aluminium with zinc. Use aluminium granules. Replace aluminium with magnesium. Now, I haven't really researched much on thermite reactions, so I need to go back and check. What should be done to obtain a reaction that releases more heat? So I want a stronger reaction. So the answer here is, let me see what the answer was. For some reason I didn't catch that part. The answer is supposed to be D. Replace aluminium with magnesium. Okay, so let's see why. Potassium, sodium, calcium, magnesium, aluminium, and aluminium, zinc, iron, and so on. Okay, zinc is lower than aluminium, so it's going to produce a less vigorous reaction. So you don't want to use zinc, but we can use magnesium because magnesium is more reactive than aluminium. So if it's more reactive, it will produce more heat. So that's why we have to replace aluminium with magnesium. So B is definitely wrong. Aluminium powder and aluminium granules, they are almost the same thing. So if they're both the same thing and we only have one correct answer, are you sure they're both correct? I mean, that's how I would think of it. But it wouldn't. If in my opinion, it wouldn't actually make the reaction release more heat. It's more of the reaction becomes faster, so it doesn't do much. You have to change it with magnesium for it becomes more vigorous, more heat. The position of carbon in the reactivity serials of metal. Oh, this is the sus part. Okay, it's between aluminium and zinc. So potassium, sodium, calcium, magnesium, aluminium, carbon, zinc, iron, tin, lead, hydrogen, copper. Okay, so carbon and hydrogen. The difference is carbon's position actually changes. I forgot how it changes, but I think the main thing you have to know is in the reactivity series, it's between aluminium and zinc. So it's C. 24. Last question. The following ionic equation represents a redox reaction. Which statement is correct? A. Silver ion is oxidized. No, silver ion got reduced, so it's not this. Silver ion is reducing agent. No, it's an oxidizing agent. C. Aluminium atom undergoes oxidation. Since it does gain electrons, so it does undergo oxidation. Receives electrons? No, it lost electrons. The electrons got donated to silver. So the answer is C. Okay, I also